Hello everyone. I am Manoj M S from Venkateshwara College of Engineering from the Department of Electronics and Communication Engineering. My technical seminar is on IoT for high-speed railways under the guidance of Professor Jayalakshmi ma'am. These are the contents: introduction, literature survey, methodology, results, applications, conclusion, and references. Let's begin at the introduction. High-speed railway is a railway system that renovates existing lines to achieve a moving speed above 200 km per hour, or specifically builds high-speed new lines to realize moving speeds of more than 250 km per hour. IoT may be used in a variety of ways to enhance high-speed rail systems, safety, effectiveness, and passenger experience. IoT technology has the potential to completely transform the high-speed rail sector, improving passenger convenience, safety, and efficiency. IoT is being utilized more and more in transportation industry and also high-speed rail systems. IoT sensors are used to track the operation of trains and other equipments, state of railway tracks, bridges, and tunnels. IoT ticketing system can also speed up the ticketing procedure and give passengers real-time updates on train timetables, delays, and other crucial information. Let's move on to the objectives. The objectives are to improve safety through a reduction in the likelihood of accidents, equipment breakdowns, and other safety threats. To increase efficiency through timetable optimization, delay reduction, and an overall improvement in the flow of train traffic. To improve passenger experience, to lower the energy use in carbon emissions by using IoT sensors, which monitors and optimizes the energy use. To anticipate maintenance needs and see probable equipment breakdowns before they occur. This is my literature survey. These are the papers I have referred to. The first paper is by the authors M.Y. Research on the application of Internet of Things technology in railway transportation, science, and technology innovation, published in the year 2017. The pros were improved safety, enhanced efficiency, and real-time monitoring. The cons were high cost, cybersecurity risk, and limited interoperability. Second paper are by the authors Oju, Waitek and Jacob. Internet of Things for Smart Railway Feasibility and Applications, published in the IEEE Internet of Things Journal in the year 2018. Its pros were predictive maintenance, enhanced passenger comfort, and the cons were reliability issues, complex integration, and data privacy concerns. The third paper is by the authors Prashant Singh and Zainam LB, research on the IoT for sustainable railway transportation, past, present, and future. The pros were reduced carbon footprint, energy efficiency, improved passenger experience. And the cons were complex integration, high implementation, cost, limited communication protocols. B.S. Dande and U.S. Pacherney research on unmanned level crossing controller and rail track broken detection system using IR sensors and IoT technology was presented at 2017 IEEE International Conference. In which the pros were greater accessibility, improved accuracy, and enhanced security. And the cons were workforce disruption, technical complexity, and data privacy concerns. Next, moving to the methodology. The first stage is to determine the precise needs for the high-speed trains that can be met by IoT. This could involve tracking of trains and rails, real-time passenger data, and proactive rolling stock maintenance. This also includes identifying the type of sensors and data that need to be collected. The next stage is to establish the IoT architecture that will be used for the development once the requirements have been established. This involves deciding on the sensors devices, communication protocols, and data management systems that will be applied. Before the IoT solution is widely implemented, a proof of concept should be created to evaluate the technology and its capabilities. Setting up a small-scale deployment to gather data and test the system will be required for this. The IoT technology can be scaled up and used on a bigger scale across the high-speed rail network once the proof of concept has been proven successful. Monitor and maintain the system. Ongoing monitoring and upkeep of the IoT system is necessary to make sure it is operating at its peak efficiency and providing the expected benefits. To maintain the system current and secure, regular updates and security patches should also be applied. This is the diagram of framework of HSR IoT. It consists of HSR IoT applications like intelligent scheduling, smart ticketing, security monitoring, warehouse management, equipment operation and maintenance, and engineering and construction. This is the architecture of IoT system, and it consists of the three layers: the application layer, the platform layer, and the network layer. Next, we'll move on to the block diagram. It consists of track sensors, which are placed on rails to track the train's location, speed, and other important factors. The sensors may identify problems, including hot wheel loss, rail brakes, and bearing overheating. Next is the train sensors, which are the devices that are mounted on trains to track various aspects of their status, such as engine performance, temperature, humidity, and other factors. Station sensors are deployed in railway stations to track environmental variables such as temperature and passenger traffic. And this is the IoT gateway, which is a device that gathers data from sensors and transmits it to the cloud for analysis. Between the sensors and the cloud, the gateway serves as a conduit. Next one is the cloud analytics, which is received by a cloud-based platform called Cloud Analytics, which then analyzes the data using machine learning techniques. The analytics platform has the ability to identify abnormalities, anticipate problems, and improve train timetables. The data collected from the sensors transmitted through IoT is sent to the train and the station computer. This is all about the block diagram. And the results obtained where IoT sensors can be used to track train speed and track conditions, providing real-time data that can be used to detect delays and prevent accidents. IoT analytics solutions can be used to schedule maintenance in advance and predict equipment failures, which will save downtime and boost reliability. Moreover, real-time data on train schedules, delays, and other pertinent information can be provided by IoT applications like passenger information systems, improving the passenger experience. The need for dependable network connectivity and power supply, as well as infrastructure requirements, provide difficulties for the introduction of IoT in high-speed train systems. Finally, the conclusion where the adoption of IoT technology in high-speed rail systems has the potential to completely transform how the systems run, bringing about enormous improvements in terms of passenger experience, safety, and efficiency. The literature review has drawn attention to the use of IoT sensors to measure train speed and track conditions, providing real-time data that can be utilized to prevent accidents and lessen delays. The passenger experience can be enhanced by IoT apps that offer real-time information about train schedules and delays, such as passenger information systems. The applications are remote monitoring and maintenance, track condition monitoring, train speed monitoring, information system for travelers, improved passenger experience, finally the safety and security. These are the references. First one is by D.S. Dande and U.S. Pacharne, Unmanned Level Crossing Controller and Rail Track Broken Detection System, published in the year 2017. Second one is by the author M.Y. Low, published in the year 2017. Next one is the IoT for Sustainable River Transportation, Past, Present, and Future by Prashant Singh, Zainab Elmi, Vamshi Krishna America, and Junayat Pasha, published in the year 2022. Next one is the IoT for Sustainable Railway Transportation, Past, Present, and Future. Next one is Pojo, YK Kim, and J Kim, IoT for Smart Railway Feasibility and Applications, published in the IEEE Internet of Things Journal in the year 2018. Last one is by the author CX Shaw and ZY Fig, research on the optimal capacity allocation and the random passenger demands in the high-speed rail network, published in the year 2020. Thank you. Thank you.